Unity. It started as a small tool made by 3 developers in Denmark back in 2004, and it grew into one of the most widely used game engines in the world. Unity works by giving you a large visual workspace where you place objects, add behaviors to them, and build your game piece by piece. It uses a programming language called C#, which is readable and well documented, making it a solid choice for people learning to code for the first time. Unity handles both 2D and 3D games, runs on almost every platform you can think of, and has an enormous library of ready-made tools and assets that developers can buy or download for free. Many mobile games you have played were built in Unity. It does have a reputation for needing some optimization work to run smoothly on lower-end devices. Unreal Engine. Epic Games released the first version in 1998. Originally built to power their own first-person shooter games, and the technology inside it has only grown more powerful since then. Unreal is known for producing visuals that are extremely close to photorealistic, which is why it gets used not just in games, but in film production. It uses a language called C++ at its core, which is more complex than what Unity uses. Games like Fortnite and many major console titles have been made with Unreal, and its rendering technology, called Lumen and Nanite in recent versions, sets a high bar for what games can look like. Godot. This engine was built differently from the start. It came from 2 Argentine developers who later open-sourced the entire project, meaning anyone can use it completely free and even look at or change the underlying code. Godot uses its own scripting language called GDScript, which was designed to feel simple and clean, somewhat similar to Python in the way it reads. There is also support for C# if you prefer something more familiar. What makes Godot stand out beyond the price is its node and scene system, which organizes everything in a game into small, reusable pieces that connect together in a logical way. It handles 2D particularly well, arguably better than many engines far larger than itself, and its 3D capabilities have improved significantly in recent years. For independent developers or anyone building smaller projects without a budget, Godot has become a very serious option. Game Maker. Originally released in 1999, it was designed with one purpose in mind: making game development accessible to people with no programming background at all. For a long time, it leaned on a drag-and-drop system, though it has always had its own scripting language called GML running underneath for those who wanted more control. Game Maker is almost exclusively focused on 2D games, and within that space, it performs very well. Shovel Knight and Undertale were both made in Game Maker, which shows that the limitation to 2D does not mean a limitation on quality or depth. RPG Maker. The name tells you almost everything you need to know. This series of engines, which originated in Japan in the late 1980s, was built specifically for creating role-playing games in a style inspired by classic Japanese RPGs. You get a tile-based map editor, a character database, a battle system, and event tools, all designed to work together without requiring any programming. A complete beginner could build a functional RPG in RPG Maker just by following its built-in systems. The trade-off is that stepping outside those systems takes significant effort. If your game idea fits the classic RPG format, towns, dungeons, turn-based combat, dialogue, RPG Maker handles it with very little friction. Games like Yumi Nikki and One Shot were made with it, showing that even within its narrow lane, creative and emotionally resonant work is entirely possible. G-Develop. This is a newer engine that positions itself as one of the most beginner-friendly options available today. It runs in a web browser as well as a desktop application, and it uses an event-based system rather than traditional coding. Instead of writing scripts, you set up conditions and actions. If the player presses a button, then the character jumps, and the engine translates that logic into a working game. CryEngine. It came from Crytek, a German studio, and was first shown to the world in 2004 through a game called Far Cry, which stunned people at the time with how realistic its outdoor environments looked. The engine was built to push hardware to its limits, and that ambition has stayed central to its identity ever since. CryEngine handles large outdoor spaces especially well. Dense forests, open terrain, realistic water and lighting. It is a serious tool for serious projects. But it is not where most people start. Open 3D Engine. Amazon entered the game engine space by licensing CryEngine technology and releasing Lumberyard in 2016, initially with a focus on connecting games to Amazon Web Services for multiplayer and cloud features. The project later transformed significantly. Amazon donated the codebase to the Linux Foundation, and it was relaunched as Open 3D Engine, or O3DE, in 2021, fully open source and free. Construct. This is a browser-based engine focused entirely on 2D games and designed to require no coding knowledge whatsoever. Construct has been around since 2007 and has a well-established community. It runs inside a web browser, which makes it accessible from nearly any computer without installation. Solar 2D. Originally known as Corona SDK, this engine has been around since 2009 and was primarily used for mobile game development. It uses Lua as its scripting language, which is lightweight and relatively easy to read. When the company behind it shut down in 2020, the engine was open sourced and renamed Solar 2D, kept alive by its community. It focuses on 2D games and performs well on iOS and Android. Pygame. This is not exactly a full game engine in the traditional sense. It is a set of Python modules that give you tools to handle graphics, sound, and input while you write the rest yourself. It has been used for education and small projects since 2000. Because it uses Python, it is an extremely common starting point in programming courses and tutorials. The downside is that Pygame gives you far fewer ready-made systems than a dedicated engine does, so you end up building more from scratch. That is also the upside for some people.